Good afternoon and a warm welcome from the Passivhaus Trust team. My name's Paul Bourgeois and I shall be chairing the session today on handover maintenance and passive house living. If you are new to the Passivhaus Trust, then hopefully the next 2 hours will be informative and enlightening. We have two sponsors of our session today, Max Fordham and Airflow, who you'll hear just a very brief introduction from in a minute. If you haven't attended one of our in-person or online events before, hopefully you'll learn something new or gain some further insights and enhance your passive house delivery experience. Today's session is one that we were planning to have just before Christmas, and for a number of reasons we postponed it till January. So it's the fourth of a series. There were 3 others last year. And we're taking a deeper dive today into handover maintenance of passive house living. You'll see that the session is being recorded. And after today's webinar, you'll be sent one of our electronic party bags with a link to this recording, guidance and other useful information. So before I introduce the speakers today, could I just ask Ian from Airflow, please, just to say a few words about Airflow.
Hi everyone, thanks for having us today. Yeah, Airflow are delighted to be sponsoring the webinar today. And just to give you all a brief introduction to ourselves, Airflow, we've been in the HVAC, heating, ventilation and cooling sector for over 60 years. We actually began by making airflow measurement devices in a small factory in High Wycombe. And we are actually still based in High Wycombe today. So we're originally known as Airflow Developments Limited. This was creating all sorts of airflow measurement devices to measure the air of extract fans. So since then, we've expanded our product range. Our main core products nowadays are things like your bathroom extract fans, be it the intermittent or continuous fans. We also do centralized MEV units, which are mechanical extract ventilation systems, and as well as our MVHR systems, which are Passive House certified. We do a range of MVHR systems for residential applications and also for commercial buildings. We have one of the largest range of Passive House certified MVHRs, which you can view either on our website airflow.com, or you can visit the Passive House Institute site, and you can view them on the components database there. So we have a team that are able to assist on any types of passive house projects. We can assist with the ventilation design, the ventilation layout. We also offer the complete system, so not just the MVHR units. We also offer the ducting and accessories. Nowadays, we're encouraging installers and designers to opt for semi-rigid ducting systems to go with their MVHR systems. Number of reasons, but mainly it's one of the easiest types of ducting to fit and install, but also there's zero leakage and very, very low pressure drop when you're using a semi-rigid system. So yeah, Airflow are a manufacturer of ventilation solutions. We also assist with all things ventilation, be that your designs or just any queries or questions you may have on ventilation, why it's needed, what's the best system to use. So yeah, that's us.
Thank you very much, Ian. We also have a co-sponsor at Max Fordham. Please feel free to look at their website, maxfordham.com. So without further ado, we've got 5 very experienced and knowledgeable people who've all delivered passive house projects and are going to give us insight into handover maintenance and passive house living today. And the first speaker up is Jill Zhao. And Jill is from the University of West England in Bristol. So over to you, Jill.
Thank you, Paul. Good afternoon, everyone. I'm so thrilled to see so many people joining this event. Thanks for the invitation. And today I will be briefly talking about user experience and behavior. And so this is based on a chapter that I've written for Passivhaus How to Build Guide, a good practice guide. And the chapter title is Handover, Soft Landings, and POE. And the basic kind of idea of this chapter is to find out a way to support the residents to achieve the maximum benefit provided by Passivhaus system. So to introduce myself a little bit more, I am an academic. I'm a senior lecturer in architecture at the University of West of England in Bristol. I have worked in practice before in London, in Beijing, and Edinburgh many years ago. I didn't work on Passivhaus Project, which was a shame, but also it's probably why I kind of start to think there must be a better way to design buildings and make them more energy efficient. And that was when I went back into academia and did my PhD in architecture at the University of Edinburgh. And it was specifically on Passivhaus and occupant behavior. So after that, I worked in research, and I worked with different external partners, local authorities in Lincoln, in Bristol, and I contributed to UK parliamentary inquiries, and I'm a member of various professional bodies. So back to my research. My research is all about looking at people living in Passivhaus and how do they use it, and how they use the energy, how their behavior changes. So as Jenda quite rightly put it, buildings don't use energy, people do. Occupants play such an important role in buildings' energy performance. And their behavior is influenced by their background, demographics, occupancy pattern, knowledge, their attitude, value pattern, culture background, and etc. And especially important is the support they have received. So you can have a very well-designed building that could achieve a great performance like a Passivhaus project, but without proper user behavior, you could still manage to find a performance gap, which means your anticipated energy use doesn't match the actual energy use of the building. In occupying a Passivhaus, some aspects of it can be quite different to occupying a conventionally designed and serviced building. This is especially true for social housing tenants, as I found in my research. So in a Passivhaus, you normally wouldn't have a central heating system. You wouldn't have radiators, for example. What you will have is mechanical ventilation and heat recovery system. And quite often you might have other systems on top of it, such as PV panels, such as solar thermal hot water generation system or a wood burning stove. So all these extra systems will create a type of barrier to users that are not familiar with this system. So it's important for the users to be aware of the principles and particularities of operating a Passivhaus, where certain behavior adaptations are welcomed to ensure the optimum energy performance and comfort. And in my research, those behavior changes do occur. So some behaviors are comfort-driven behavior changes. For things like because of living in a warmer house, they would change into cooler clothes, thinner beddings, or they learned behaviors to operate windows, blinds, curtains more efficiently to prevent overheating. They learned how to operate the MVHR. They changed their sleeping habit, sleeping in a cooler bedroom, or shifted their focal point in the living room to another point so that they don't get the heat from a wood burning stove, for example. These are comfort-driven behavior changes. And there's also energy-saving driven behavior changes that I found. So these include, for instance, they're more patient on a slow response system due to the passive nature of Passivhaus system. to use the internal GINs rather than active heating device. They have developed the habit of checking the weather more frequently so that they can operate the house based on the weather. And they're more mindful of additional energy use. They learned behavior to use electric appliances more efficiently. Some of the occupants, more scientific-minded, they added a weather station to monitor the weather. They have different signals to tell them when to turn something on or off. Some of them keep an energy data log as well. And more interestingly, and I think more importantly, especially for social housing projects, quite a few of them formed a community in their neighborhood. So there's a community-based learning on energy efficiency. They learn from neighbors. They have energy auditing quite often. So it's a very good opportunity for social housing passive house to form this kind of energy efficient community. And all these changes will not be possible without proper support. So that's why when I've been asked to write a chapter on handover soft landings and POE in the how-to guide, I was thrilled. So I devised, in the second edition, I devised 4-step guide for housing associations, social housing providers, and design professionals to better support the residents. And I'll briefly introduce the 4 steps here. Step 1, it's all about understanding the basic principles first, tell the residents what to expect. And this should happen much earlier than their move-in date. So the prospective occupants should be introduced to the basic principles of passive house, such as the working principle of MVHR prior to their moving day. And this could include a series of client meetings, user consultations, site visits, and the illustrated guide, for example. And they should be explained that the energy consumption will partly be determined by how the occupants use the building. It's not automatic. So that's the first step. The second step happens on the moving day. So it's about a quick start to get the residents up their feet, start control the house to their liking. So this could include stickers or laminated graphic instructions affixed to plant, to include a simple quick start guide, and some short specific how-to videos, and identify who to call, the person to call when something goes wrong. So this needs to be quite quick and sweet. I visited a Passivhaus Social Housing project where the only guidance the occupants got was a very thick book, an instruction manual, and some of them was written in German. So they were very much at loss of what to do. So that's the second step. The third step is during the initial occupancy stage, which is after they move in, but no later than 2 weeks after the occupancy. So this is about a kind of starting them to form a community, to trial and error into their learning and feedback session. So these could include you walk through the residents with this quick start guide, have 1 or 2 Q&A sessions, and encourage the residents to learn by doing, by setting different controls and operating their homes, and then to repeat a similar session at the change of the season, as well as designate a project team to respond to any difficulties the residents might have. So in this way, we start to form a kind of community which has proven benefits in encouraging sustainable behaviors and improving the lived experience. So with these 3 steps, the residents should have a pretty good idea of what they're doing, how to achieve comfort with relative less energy consumption than what they experienced before. Now, the 4th step comes in as a longer term support. So it's to continue the support into 1 year, 2 years, 3 years, even longer into their living, to monitor and to troubleshoot. So this continuous support is so important to try to keep the communication channel open for occupants who want to go to the extra mile to save energy. So these could include informal quarterly energy audit sessions, regular newsletter as reminders, or to have the occupants on board to conduct post-occupancy evaluation to actually see what has worked, what hasn't worked, what can we do better to maximize the benefit and to save more energy. So these are the 4-step guide into supporting the residents. And to conclude, I think it's very important. It's such a great cause to try to push passive house standard in social housing. So in my research, only 3% of social housing providers in the UK adopted passive house standard in their portfolio. That's not a lot. And all stakeholders in this process, developers, housing associations, councils, and designers and the maintenance, supply chain, as well as residents, should all come together to advance this course to build more passive house standard social housing projects. I think it's hugely important. And that is why I'm currently researching on this topic and preparing to develop a pilot Excel-based decision-making toolkit together with Passivhaus Trust. And it will be suitable for social housing providers across the UK in assessing and supporting decision-making process to carry out a passive house project. So stay tuned, watch this space. I'm not going to be able to stay for the whole session, but please email me or find me on Twitter. I'm on every social media platform. So connect with me and tell me your comments. Tell me what you think. Thank you very much.
Thank you, Jill, and very well timed. We are going to hold off questions until after the second speaker. Jill will be able to stay for that short Q&A session before the third and fourth speakers, and then there'll be a more general Q&A where we'll look at the questions that have been posed on the system. So without further ado, I'd like to ask Tom Dollard from PTE, who's our next speaker, and Tom's going to give us some greater insight into performance data, which is quite a rare beast still today. So Tom, over to you.
Thanks, Paul. Can everybody see my slides? Yeah, I think it can. So yeah, building performance data is a hugely rare beast. Every few years it comes along and we all get to see what actually is happening in the buildings that we design and see completed and then hand over. So I was lucky enough to get involved in actually many projects, but this is probably the biggest project in the last decade that's been funded by government. It's called Building for 2050. I'm sure some of you have been aware of it and may have been involved. And I'm going to take you through the performance data, specifically the energy, thermal comfort, and air quality data. It is a huge project. It was 5 years, multidisciplinary team. So there's a lot of findings there. It's all on our website. Multiple reports and films actually that we had fun filming. So I've only got 20 minutes. I'm going to try and be shorter so we can discuss. So I won't be able to go into too much detail, but please do put in the chat if you want me to expand on anything. I'll give it my best go in the chat following this session. I should say just a word about myself. I'm an architect, partner at Pollard Thomas Edwards. We're a well-established architecture firm. We like to think we're at the forefront of the climate change agenda. We've been working for government on the Future Home Standard recently, and we've just been in the press getting planning for a large Passivhaus scheme near Oxfordshire, which you may have seen. That's a bit about PT, and now on to the presentation. So this is Building for 2050, finished last year. these are the key players, led by AECOM and ourselves as architect lead, site review lead, and communications kind of resident liaison as well. Well, with Four Walls, you may know Ian Maudit, celebrity of building performance evaluation. He's also working with us on the new Part L and Part F, the consultation that's out now. And LCP Delta specialists on the services and grid supply systems. So introduction to building for 2050. It's looking at low cost, low carbon housing. How can we scale up low cost, low carbon housing? And this was 8 years ago, the project started. So we had quite different views on what low carbon meant. And Bayes didn't define that. We deliberately went out to market to see what people defined low carbon housing. And most people defined it as operational energy, but in the last, I'd say 5-6 years, it's certainly embodied carbon has become more a focus. And then within that operational energy and carbon, there were many different views on what people thought that meant, from the kind of active house approach, the Passivhaus Plus approach, through to the Passivhaus standard, through to the ACB standard, Passivhaus standard, the low energy building standard, and then the kind of non-standards, the things like people saying it was energy positive and zero carbon and low carbon. So there's a huge piece of work to define what people meant by low carbon and what people were doing. And we went out to about 30 case studies to get some data from. Some of those were Passivhaus projects, projects in Plymouth and around the Norwich Passivhouses, Goldsmith Street, but the majority were not, and that was mainly because there just weren't, 7 years ago, there weren't enough Passivhouses to go and assess on site and have the right timing and program to go and get a 1.5 years data in use. So these 4 case studies presented today kind of hit the sweet spot of being low carbon operational. Some of them started out with Passivhaus ambitions like Marmalade Lane and Utopia Corby, but then they weren't certified. And if we get time at the end, we could possibly discuss why that wasn't the case. And then Active Homes Neath was also this active house methodology, which is meant very similar to Passivhaus Plus or Passivhaus Premium, but without the certification, so that various merits and disadvantages of doing that. And this is what we did. So it was a whole load of research, essentially a survey of residents, very much resident centered as well. And I won't have too much time to talk about what residents said, but again, in the chat, if you'd like some insight into that, we can certainly discuss. And then this is really interesting because this is very similar to Jill's work. This is the kind of summary findings, the diagram that we produced at the end of 5 years. You probably could have guessed or put this together without all that research, but we wanted to set it out in a diagram format, and essentially saying that a developer needs to have a holistic approach. We all know that. It needs to focus on collaboration and coordination before site, and possibly we don't all realize the importance of design coordination and procurement coordination before you start site. That was certainly lacking in many of the case studies. And then, the technical importance of having products, the right ventilation products, heat pumps, PVT, whatever the technology was, that's certainly a barrier and an enabler. And then funding routes, so how affordable housing is being funded at the moment is arguably lacking and is not focusing on skills or awareness. It's more focusing on kit funding, heat pumps funding, innovation for the building services plants rather than the actual installation. And then on the resident side, and this is obviously linked, and it's a resident process brief, residents are the core to the brief. We obviously spoke to them at various points in the process, and it was quite clear they wanted all these things. And it's very obvious that you want a home that doesn't overheat, it's easy to maintain, it has low energy bills. This was quite unusual, actually. A lot of the industry didn't really value low energy bills, or thought that residents wouldn't pay more for it, but our research showed that they would pay more for a house, a flat that had lower energy bills. And so again, it's holistic design. And one of our findings was that if you just focus on carbon or energy, or even indoor air quality and comfort, like the Passivhaus standard, you can sometimes miss other stuff that's arguably more important, possibly around the social side of how you use a home. And I think the case study showed, so I'll talk about the case studies in a second, but the case study showed how if you go that high-tech route, so that the zero carbon on site or the energy positive on site, it really does force you down a high-tech route. And that created quite a lot of unforeseen consequences on usability of the kit, maintenance of the kit, and reliance really away from the fabric into this kind of system that required the user to be trained, which we didn't really want to do. You know, these homes should just be designed to work, was the argument. So I'm going to touch on the 4 case studies, 4 of them. Marmalade Lane, very well publicised, multi-award winning development by Town, Mole Architects and various other consultants there. This we think is, you know, this aimed for passive house at planning, and actually was then value engineered down to a kind of AECB standard. But I think the critical thing for success is they modeled it in PHPP. They realized at the end of terrace here, some of the flats weren't meeting the 15 kilowatts. So they stuck to a number, and I think it was 35 or possibly 40 kilowatts. So they kind of stuck that in there, and then it did slightly get value engineered, but you can see they've got the basics of a fabric first approach. Arguably that's a woolly term, doesn't really mean much, but certainly in terms of the wider design, it was relatively successful in terms of its performance and relatively successful in terms of its resident satisfaction. Key items, it was an off-site manufactured closed timber panels, the Passivhaus system from Sweden, triple glazing obviously. The glazing was installed in the factory, so very good air tightness around the seals. The timber frame is built around the window, which is a very good way of sealing those windows and doors. Air source heat pump obviously, and MVHR. Next case study, Active Homes Neath. This is the first project that the Active Building Centre did at scale, or any sort of scale. And so there's lots of lessons learned here, and really a whole catalogue of issues that the design team and contractor had to deal with. Everything from going up to 3-phase electric, to trying to heat through the air, but not going to a Passivhaus standard. So they had issues with the heating system, which was an air-based heating system. They had PV on the roof here. This is a PV film, which was very successful, but they had these transpiring solar collectors on the elevation here that were less successful. They were acting as a preheat for the heat pump. It's a heat pump for the hot water, I should say. So you can see the details there, and there's loads of details online about this scheme. Third one was Etopia Homes in Corby. This is a modular system and going for active, so energy plus on site, being a net provider of energy through lots of PV and PVT panels and a smart energy system. And then finally, Tallock Road in Waltham Forest. It was an apartment scheme, and I think it was the first one to use this ambient loop that now seems to be mainstream, ambient loop communal heating system. Less focus on the fabric here. It was traditional build, part L U values and air tightness, more about just plugging in this communal heat pump system. So the findings, and my team went to site probably about 8 times during construction for each one of those case studies. We interviewed all the stakeholders, everybody from the client all the way through to the carpenter and the ventilation installer, the plumber, whoever would speak to us on site, basically. So a lot of the findings, what we did was we noted the findings down on this sort of matrix. You can see a table here. There's a standard form. We noted what the design was and then what the findings were on site. We then used this data to contribute to an as-built SAP model. So we used SAP. We also tried it in PHPP, but because none of the other design team were using PHPP, we just decided to use SAP. And it's a way of tracking the performance gap. It's a way of tracking what were the issues on site. Why was it a problem? Was it a buildability issue, a cost issue? Why were these things changing from design to handover? And you can see us on site measuring. A lot of this is just site observations. It's just the good old eyeball test. It's not anything technical. It doesn't require any instrumentation. Just being on site and asking the right questions. We essentially found that low carbon housing is nearly always electric. There was no gas. It was nearly always heat pumps, and that complex designs were certainly an issue. We've known that for a while. Keeping it simple is certainly has lots of benefits. On the cost, again, these are quite surprising. So where a scheme had grant funding for innovation and advanced kit, it obviously spent that money on the kit, so it went over budget compared to a baseline scheme if you're using the RICS methodology. So we found the active homes Neath had a 20% grant for that kit, and it obviously spent that, so it went 20% over a Part L baseline. So that's an example where I think funding is not really helping the argument, but the private developers who didn't have any funding delivered these case studies for 1 to 2.5% extra. It's very minimal. They were able to value engineer a lot of certain things out by really focusing on coordination and good design. In terms of the skills gap, there certainly is a huge skills gap, and it's across the whole industry. It's not just at skilled labor levels, it's also in MEP services design. It's in that coordination piece between fabric and design, and at developer level as well, kind of not understanding the issues around connections, utilities, and again that coordination between fabric and services. MMC, I think 3 of the 4 case studies were a panelized solution, timber or steel. We certainly saw benefits from using those on the kind of high level. So perhaps the U values were better, more efficient. It does depend on the coordination with site and the interface between the slab, for example, that's poured and then the panel that comes off is critical. We did see a positive correlation between MMC and thermal performance, though. So I think it's fair to say that generally it did produce better thermal performance. But it massively comes down to the details of the design, though, exactly how that performs. And then in terms of fabric performance, we did all that eyeball test and we created an as-built model. We then, towards completion, we carried out various fabric performance tests, and some of you will be aware of the co-heat test, which is the kind of gold standard for that. Carried out that. We did a second, third air test, which was surprisingly different from the developer's air test in many occasions. The fabric was generally a lot better than Part L. These are schemes that were aiming for Part L, so it was better, but they didn't meet their design targets. 4 of the schemes was 10% worse than predicted, and 1 scheme had 100% worse fabric performance. In terms of the air tightness, that was probably the key issue here, that and thermal bridging. So air tightness, again, I think if you've been around Passivhaus for a while, you'll know the importance of air tightness and the various issues. On screen here, you see you've got some patio doors. So patio doors, and sliding doors are generally not airtight. So that's evidence there, and duct, ventilation duct, and light services going through the fabric as well is an obvious air sealing issue. Thermal bridging was another key issue across all these case studies, and again, it's obvious if your U values, if your 2D U values get better, then thermal bridging starts to become more important. And so we started seeing that in these balcony, which didn't have thermal breaks on, again in door thresholds, key areas of thermal bridging, and we found bits of thermal bypass as well. There's a few roof details and houses that had thermal bypass and going behind the plasterboard service zone detail. And then after that kind of handover testing, we carried out some more intensive or longer term monitoring. So this was at least a year's worth of data for energy and environmental testing. So environmental is CO2, temperature, humidity. You can do other indoor air quality, but CO2 is generally a good proxy for the other measures. And the results are here, and they're on our website and in the report, so you can go and look at these at your leisure. I'll just pull out some of the things about space heating. So space heating, there was a significant performance gap of between 2 and 4 times worse than predicted. So you can see the actual fuel use there is in orange, and the developer's design predictions are in red, and then our adjusted design based on site findings is in blue. So you can see by going to site more often and noting the changes and then modeling those changes in SAP, or you could use PHPP, you're getting a much more predictive, better model. And that's across space heating and also hot water. In terms of space heating, that's, yes, significantly worse than the design. And that holds with current literature on the performance gap, typically, yeah, between 2 and 3 times worse than the design across most types. There's various papers out there showing that Passivhaus has better performance in terms of performance gap. So hot water, this is actually better than predicted. I think residents used hot water less than predictive in terms of SAP. That's down to occupancy and use. So you can see orange is the actual hot water use and red is the predicted. And CO2, the CO2 across most of the developments, you can see the green stack is the, so this is the carbon emissions, not the CO2 levels. This is carbon emissions. So you can see again, we just modeled the CO2, so carbon in operation. And again, this shows the performance gap, the issues between a SAP model that's built by a developer, and then when you go along and test it and monitor over 12 months, the differences between those. And then just finishing off with comfort and indoor air quality, it's worth spending a bit of time on this to finish off. So 3 out of 4 of these case studies, and we interviewed all the residents, or as many residents as we could, on the developments. It's always quite tricky getting their permission to do that. But as many residents, we had a sufficient sample across all 4 case studies. And I think the overall findings were that generally they were very happy in winter months. I think the summer was certainly a bit of an issue for 2 of the case studies. So I think there's a lesson there. Even if you're not doing Passivhaus, if you're going to kind of improved fabric and not necessarily thinking about overheating or improved ventilation, then you obviously need to do that. So generally very good during winter months. There was some instances of condensation in new build, which unfortunately is not is not unusual to hear of condensation in new build. And generally that was as a lack of ventilation. So it was the background ventilation system's not working. I should say that 3 out of 4 of the case studies had MVHR, and 1 of them had MEV, continuous MEV. So in 2 of the schemes, residents said the air was dry, and that was confirmed by monitoring. We had kind of humidity levels below 40% in some instances, and that was generally caused by overventilation and poor commissioning of the MVHR. So combination of the product possibly, but also the length of ductwork. So there's a design issue, and then the commissioning at the end not being balanced, not being commissioned properly. Then this is a really interesting one, and I haven't got time today to talk about all the research we did with residents in use. We had them writing diaries and all the rest, but generally they reported a lack of clarity on how to operate their mechanical ventilation system. Some of them didn't really even know what it was. It was just a box. So there are certainly issues around education of MVHR and how to use that, how to clean the filters and the rest of it. And then finally, yeah, I think I mentioned overheating. In this flat, this is an apartment flat. This is probably one of the worst ones in the corridors. Interestingly, this was an ambient loop system, so it could have been a lot worse, I think, if it was a normal hot temperature system. and there were other houses even that were overheating. So I think that's an overall finding that overheating is certainly a bigger issue than underheating, and one that needs to be addressed going forward. I think that's it. So yeah, please do have a look at the website. There is a few films there, a couple of films on the process and resident interviews and all the stakeholder interviews. And then there's 2 reports. There's an executive summary that has the findings in 2 or 3 pages. And then there's a 200-page report as well with all the data there. So please do get in touch, and any questions in the chat. Thank you.
Many thanks, Tom. Yeah, lots of data and importantly findings that hopefully we'll be able to take forward, and whether you're building to passive house or not, hopefully some opportunities there to reflect on all those findings, but and a lot in the chat. So Martin, I think you and Ulrika are our next speakers. Do you want to do those? Martin and Ulrika are going to do a double act. I'll briefly introduce them, but I'm sure they'll introduce themselves. So Ulrika is from Passivhaus Housing Association, and Martin been working with Passivhaus, and in particular the development at Wimbish. They're going to talk to us about 10 years on for a number of years, but I'll let them introduce themselves. Have you got your slides there, Martin?
Yeah, so I just introduced myself briefly. I'm Ulrika Macariello. I'm Development Director at Passivhaus Housing Association. Martin, do you want to introduce yourself?
Yes, I'm an engineer, an independent consultant, been working with the Passive House community for the last 12 or so years. And part of that has been a long-term exercise studying Hassto's Wimbish Passive House development.
Right, do you want to go to the next slide? But Martin is doing most of the talking, so I'm just, I've got a few slides, so Martin is doing the driving, so you get the next slide. Request me. Not yet, not yet. So Hassto is we are a rural housing provider, so most of our schemes are in villages, and they are normally quite of a small size, so you know, typical schemes of ours are around 10 units. Hassto has got a long history of delivering sustainable housing projects, and really one of the main aims is to address rural viewer poverty, because we know that our residents really struggle to heat their homes and stay comfortable in the winter. And that was really a driver for our scheme at Wimbish. We wanted to have a highly sustainable construction project, and we decided that the Hassto board decided that in 2009 to develop a passive house project. We engaged quite closely with the community, and it was really interesting that when I mentioned passive house to the parish council in Wimbish, that they actually knew what passive house was. In 2009, that was very rare. And we were also very lucky that the local authority had a sustainable officer at the time who was very supportive of passive house and didn't just insist on like having lots of additional kit added to the project. So that was really good. This was the first social passive house scheme that was delivered in the country. So it raised the profile quite a lot, and it was an exemplar scheme for Hassto, the first one, but we wanted to find a system that we could replicate on other schemes as well, and that we did. We also raised quite a lot of awareness with the local authority on this scheme, and also the wider sector. We held a lot of experience visit sessions during and the post construction. Next slide, Martin. So the Wimbish scheme, it's 14 units in total across 3 blocks. We've got 6 one-bed flats in 1 block, and then we've got eight houses, a mix of 2- and 3-bed houses. The construction method was thin joint block work with externally applied insulation, and then render. We've got MVHRs in there, solar thermal, and the solar thermal system actually is the main heat source, which in line with a large thermal store, and the gas boiler is really only as a backup for when there isn't enough hot water produced by the sun. And we completed and occupied the scheme at the end of 2011. Next slide. Because it was the first scheme for Hasto, and it was quite an exemplar scheme, generally in the country at that point, we wanted to monitor the performance of the scheme, also to give us more confidence going forward. So we managed to obtain funding for monitoring for in-use and post-occupants evaluation. And we worked, or we engaged with the UEA, University of East Anglia, and that's how we found Martin, who is like an independent building performance evaluator at that time. So it was quite important that we had somebody who was independent, who wasn't previously involved with the scheme, to make sure that the monitoring was really independently evaluated. And the funded project was for a 2-year monitoring study, but then we jointly agreed between Hasto and Martin that it would actually be really good to continue with the monitoring. And overall, we did just over 10 years when we did a follow-on survey, and then Martin produced a report, which Martin is now talking a little bit more in detail about it. So over to you, Martin.
Thank you, Ulrika. As well as having 10 years performance data, temperatures, energy use, humidity, air comfort, we carried out after 10 years a number of exercises, rechecking the air tightness, looking at the ventilation system, carrying out thermal imaging, and resurveying the residents. So we've got a fairly good idea of what has happened with the passive houses over this 10-year period. And we are happy to report that generally, I mean, unlike some of the schemes that Tom was talking about, the comfort levels, the energy use has all pretty well stuck with expectations throughout that period. I must admit that the electricity use comes out as being normal. That's possibly not unexpected because a lot of the people brought relatively old appliances with them when they moved in. I wasn't going to talk any more about those issues because I knew Tom was already covering it. But what we are talking about is a little bit more about handover, which to a degree complements what Jill was saying. And there's various other elements from findings throughout the rest of the presentation. So Jill has already talked a little bit about some of these things, but for the handover, the contractor produced a short guide, about a dozen pages, and that was supplemented by some A3 sheets on how to use the MVHR. They provided some instruction before move-in for Hasto support staff, and then for the residents actually on the day that they moved in. Now, we were there, and I say we had a UEA PhD researcher looking at the behavioural aspects alongside myself. And we were there observing the handover on this particular day. And I guess it was not ideal in as much as the residents were rather more busy about where their furniture got put as they were moving in than they were learning about how to operate the MVHR or how to change filters. And we identified a number of things like the need to refresh the guidance periodically thereafter, and to deal with issues to do with changes of residence. Now, Jill mentioned this particular good practice guide. The architect for the Wimbish project, Chris Parsons, I see he's still credited with that particular section with Jill, and a lot of our conclusions from the study that we were undertaking were fed via Chris into this Passivhaus Trust guidance. I think Ulrika, you were going to cover this one?
Yeah, I will just briefly sort of update it. Jill has covered quite a lot of this before. So we generally, because we do quite a lot of consultation on the wider community, we normally have a consultation event once the project goes is live on site, so that we can update, you know, prospective tenants that they are residents, that they how to apply for it. But that also gives a good good basis to update on what the scheme entails. And on this one, we obviously sort of raised that this is for Passivhaus. And then we generally do like viewings for nominated tenants that can view their homes 4 to 5 weeks before they move in. And then, you know, that gives again an opportunity to sort of explain the difference between a Passivhaus and a conventional building. We definitely don't do any sort of training or attempt any training anymore on the move-in day, because residents are just concentrating on moving, and it's one of the most stressful events in our life. So they definitely don't take it in. And then we normally go back 2 to 3 weeks for a one-to-one face-to-face session. So we make the effort to go around each individual home, and ideally we bring the MVHR installer or manufacturer along so that they can explain. And also we try and encourage residents to actually push some buttons so that they kind of get that experience of and not being fearful of the MVHR settings. We haven't done any videos, we haven't done any Passivhaus for a while, but it's definitely something that I think is very useful for any future staff changes, and also for residents to refresh, and also for relet. So definitely something, and the technology now is so much easier to be able to provide that.
Thank you, Ulrika. That really sort of brings us on to the topic of maintenance, and it is sort of generally agreed in business and industry that if you build to higher quality, you'll get fewer maintenance issues. And I think that's something that was proven by the Japanese car industry a couple of decades ago. And people talk about that in the context of Passivhaus as well. Unfortunately, it wasn't an explicit element of the funding for the project, and therefore we didn't capture as much of this as I might have liked. But there are a number of observations that we can make, and these will come up a couple more times through this presentation. I think the main point really is to try and keep everything as simple as possible. We all know that what you do in terms of the structure and in terms of the systems that you put into a building can have a large impact on the amount of maintenance that has to be done. And it's vital, I think this is reflected also earlier, that the consultants, including M&E, are brought on board very early on, and that this also involves the maintenance side of HASTO and social housing providers, so that everyone is signed up to what they're getting. What we found was that the handover process, albeit slightly flawed, the residents did have a number of questions after they'd been living there for a while. And unfortunately, the support staff, perhaps at that time, were not as familiar as they should have been with some of the things around the house. As I've seen coming up in the chat, there's been a little bit about heating systems. The thermostat you see here is a typical one, and the advice was, well, you set it to come on for a couple of hours in the morning and a few hours in the evening, as you would any other house. Well, that's probably not the most appropriate solution for a Passivhaus. And then the MVHR controls there. 1 or 2 households with younger residents said, oh, it's just like my smartphone, it's dead easy. Other people were completely flummoxed by it and had no idea when they were supposed to say that they were going to switch to fan 1. Why would you want to go to fan 1? And the support staff, there were also 1 or 2 issues around turnover of support staff and not being able to maintain the lessons about what was slightly different about a passive house. So, as Ulrika was saying, ensuring that support staff are familiar with the house and the buildings, and preferably they have visited too, and the video materials would also be extremely useful for them. Coming on to ventilation, and again, I won't say too much about this because I know that Tom Hayward's got it as his topic. For Wimbish, there was this extensive training session. They were given this handout as to how to change the filters. It needs regular attention to make sure that the air quality isn't being impacted by dirty filters. And yes, the control panel had a little light that came up on it to tell people when filters were in need of changing. But it fairly quickly became apparent that the residents, they weren't comfortable changing them. They weren't happy having to source the new filters, and Hastel subsequently decided that they really needed to employ a service engineer to carry this out. Of course, that has been done since, and generally successfully, but the scheduling of visits was a lot more challenging than perhaps it should have been. So the lessons from the ventilation is that it's very important to get the design right, to make sure that you've got a design which is going to last. The last thing you want to do is to have to tear ceilings down to fix anything. And therefore, you really need to also consider during your design process how you're going to go about the servicing. Is there perhaps some way of enabling access to the filters from a porch or something like that? Do you need to train up your housing officers so that they could perhaps do it on their visits? And as I suspect Tom will come on to later, there will be a need at some point to recommission the system. The air supply terminals may have slipped slightly, or dare I say it, the residents may have tinkered with them, and something needs to be checked. The hot water system and heating system at Wimbish, as Ulrika said, was primarily from the solar thermal panels on the roof with the gas boiler feeding the store. And from that, there was feeds to a towel rail in the bathroom, which I'm not sure many people used, hot water provision and heating via the MVHR air. So again, it's paramount that the air is flowing to provide the warmth to the houses. We had some doubts early on because when we were looking at the installation of the kit in the plant rooms in these houses, to discover that the way the systems have been put together varied quite considerably. And there was some question as to whether or not everything was done to the standard it should have been. And when the odd household did have problems with their heating, the service engineers looking at it often had very little idea how it was actually supposed to work. The design was supposed to be that there was going to be hot water was 100% supplied by the solar thermal during the summer months, but we quite often discovered that there was quite considerable gas being used, and it could only have been used for hot water. So was this high levels of bathing? Was it because the kit wasn't working? We really didn't get to the bottom of some of those issues. So really, I think the lessons that we took from this was try and keep the systems as simple as you can. Try and ensure that the installation is of highest possible quality, perhaps involving clerk of works who's had some passive house training. You need to be sure that you don't have systems that need to be reconfigured twice a year because of seasonal changes. And I think I should add at this point, as we've heard from Tom, and air source heat pumps, you probably wouldn't do anything like was built for Wimbish nowadays anyway, and it would probably be a lot more alike anything that you'd build for the future home themes. Finally, I want to come on to windows, and window manufacturers in general, I think, would all say that their windows need lubricating from time to time, and they just need checking that the seals are all working, etc. And in a passive house, this is probably particularly important, not least because of the weight of these windows. When we came to do the 10-year tests, the air tightness of the properties we tested was a little down on the passive house 0.6 air changes per hour standard, but we're talking 0.9, not 0.10, 10, 0.1, 1 air tightness. But despite this, some of the residents were reporting drafts, and checks of the windows with thermal imaging discovered that we were getting some leaks and there were some cold spots around the windows. And I know that Hastos have since had the window manufacturer back to take a look at this, because it's quite a specialist task to adjust these windows, and also to comment that getting the replacement parts may not be as easy as you'd like it to be. So we had carried out surveys of residents throughout the period, right at the beginning, after a few years, and then after 10 years. And generally speaking, they've been extremely happy with their comfort levels, that the whole of their properties can be used. So one household was saying that they've got children with bunk beds and they could just pop the bunk beds in front of the windows, and that was not a problem at all. That they were more comfortable in bed at night, no need for hot water bottles anymore. And if they did need a little bit of extra heat, well, they just turned the tumble dryer on. They'd time its use to coincide with when they knew it was going to be cold. So they're never cold. Their gas bills are at least a quarter of the standard. Early on, people were reporting that their bills were something like £120 a year for gas, for heating and hot water. The MVHR was there and maintained the humidity levels at a reasonable level, and there were no complaints of condensation or mold. There was a little bit of dissatisfaction, noise from neighbours, but that isn't really part of the passive house standard to design the party walls. But perhaps because passive houses are very quiet to live in anyway, the noise from neighbours was perhaps a bit more noticeable. And the overheating is perhaps one of the main areas of complaint. But when we look at what was being experienced in other houses during the hot periods we've had in the last few years, we felt it was probably not as bad as they might have imagined. And one of the main issues that came out of the surveys that we carried with them is that where households felt they understood how to manage overheating, they felt far more accepting of getting a little bit warm at times. So if they knew what to do, that helped. So overall, the important things are to minimize the need for resident learning. I think there's been a little bit of talk about how users need to learn. Well, try to minimize that, keep the controls simple, and enable them just to live normally and to enjoy their passive homes. One exception might be around the whole area of overheating and how to manage the solar gain and how to throw open and how and when to throw open windows to cool down. A lot of it comes back down to trying to, well, I think we learned that people knew what to do when they went off on a Mediterranean holiday, and they just had to learn to apply those lessons at home. So passive house design now takes overheating far more seriously than it did in 2009 when these houses were designed. And of course, as well, MVHR kit is a lot more sophisticated. So in my own home here, I just let the MVHR run. I very, very rarely touch it. It knows when to go into bypass or into coolth recovery mode. I just let it get on with it. But of course, you can never account for people's use of blinds. So the Wimbish properties were all provided with blinds to keep the external blinds to keep the solar gain down. But of course, they just use those for privacy. So back to Ulrika.
Yeah, just a little bit of an update, kind of where following Wimbish, what Hastos done At the time, we completed all our schemes to Code for Sustainable Homes Level 4. And then we also had an aim to deliver about 20% of our development program to Passivhaus. So we did carry on delivering another 12 schemes following WIMBISH, and in total we've completed over 140 units. When the Code for Sustainable Homes sort of fell away, we were then a bit left not sure what to do. So we decided for a while to adopt AECB, and completed quite a few units, but financially it was not viable because the standard was much closer to Passivhaus than to the previous sort of level 4. And because of our dispersed nature of our projects, we don't have a lot of repeat contractors, so it made it quite, so you have to start afresh with a lot of consultants and contractors every time you have a project. So we then decided to develop our own new build standard, but very much based on our Passivhaus experience or fabric first approach, and trying to, looking that will meet the future new home standard as it was before the consultation came out, obviously, to kind of make sure as well that our properties are zero carbon ready, and that we don't have to do any retrofitting in future years on the properties that we're building now. We completed the first HASTA new build standard homes in 2022, and we've got quite a few under construction. You just want to move to the next slide, Martin. So we are still really committed to Passivhaus, but the cost premium is a challenge. Generally, affordable housing is a challenge. Our costs have gone up incredibly high. I know we get more funding from Homes England, but there is a sort of upper limit. So we are hoping that we've got one scheme in the pipeline that we can make work. So we always look for opportunities for Passivhaus. We're very committed to that. And then just to the final slide, I think, Martin. Yes. Yay. Which is really good. And I think it gives a lot of confidence to HASTA that it does continue to deliver. It was the first scheme. We've learned an awful lot from then. It was, forefront of Passivhaus at the time. There weren't many consultants and contractors who were experienced with Passivhaus. So it's really good to see that it does deliver, and that it provides really comfortable homes to our residents, which is the aim that HASTA had when we set out on that journey.
Brilliant. Thank you very much, Ulrika and Martin. Really good to have that decade of learning and experiences, and some of the qualitative as well as the quantitative information that you've offered, and just anecdotal as well. It's all very important to put into the mix and learn from. So now moving on to our final speaker, Tom Hayward from the Green Building Store, moving back a little bit towards the maintenance side, because as we know, like MVHR units in particular need regular maintenance and filter changes and those sorts of things. So we've asked Tom to give us a bit of insight from a product perspective. So over to you, Tom.
Great, thanks, Paul. Hi everyone, I'm Tom from a Green Building Store. We specialise in the design, supply, commissioning and servicing of MVHR systems. We've done some big social housing schemes in the past, and we've got some big ones on. So we've currently got one with 47 dwellings and another one with 17. We do present different challenges to private housing, as has been addressed already. So I'll run through a bit of that. I've been editing my slides as we go along to try and help answer some of the questions that have been raised. So hopefully that's useful. So we'll get cracking. So firstly, with regard to maintenance and servicing on MVHR systems, why is it needed? Well, your MVHR system is providing fresh air to your building, and it's extracting stale air and humid air. So it is essentially acting as the lungs of your building. Therefore, it does need regular maintenance. We've got airborne particulates, dirt and debris, which a lot of people think small dust particles and things like that. They can actually be bigger, as you'll see in some of my pictures. So you can get insects that can get inside the unit and can cause damage to components. Mold shouldn't really be an issue in your MVHR system. It's got air flowing through it constantly. So if air's flowing through it constantly, mold can't develop. Martin mentioned in the last slide that MVHR systems are becoming smarter. And that's a really good point, especially with control for the occupants in social housing. We do want the occupants to have control. We want them to be able to adjust their fan speeds if required. You know, if they get a lower occupancy, or if a new tenant moves in where there's only one as opposed to 4 previously. You want to be able to change the fan speed between 1, 2 and 3. But the older controls also allow a tenant to turn the system off, which many people do because they don't understand what it's doing. They think it's using a lot of energy, which it shouldn't do if it's well designed, therefore they turn it off. If the system isn't serviced, it can also become noisy, which again, tenants then turn them off. So now what we tend to do is provide a control where we can't turn it off, we can only adjust the fan speeds for comfort. Filters, so there's, in your MVHR unit, you have 2 filters. One is filtering the clean air that's coming into your building, and that's filtering out pollen. You can get NOx filters in there, and it's also filtering out any airborne debris, including insects, animal hairs we see a lot of, and it varies around the country. You get a lot of pollen, and if you're living near a farm, people often think we get fresh air, but it can often contain a lot of other particulates, including agricultural chemicals. So with regard to controls, there's a picture there of a controller which I've just put in. That is what we tend to use in social housing. So they can choose between fan speeds. They can boost the system, perhaps when we're cooking, and that will increase the airflow rate for a set period of time, usually 45 minutes, and then it'll go back down to standard operation. As you can see on that controller there, it does have an LED light that will flash on the filter section when the filters need changing. It does obviously need someone to do something about that. Some people might see it flashing and ignore it. Your extract air valve. So when we're extracting air from a bathroom, for example, where we've got a high humidity when showering, we're extracting wet airborne dust and towel lint, which can become collected on the air valves in the extract rooms. It can be quite a considerable build-up, even over a year, so they do need cleaning quite regularly. I've got some pictures of that to show you in just a minute. Just to mention as well, the other filter in the unit is on the extract side. So when we're extracting the air from the building, that doesn't need filtering for health reasons. It needs filtering to stop any debris, dust from collecting inside the MVHR unit and causing any damage. And intake grills. So we often get called out to MVHR systems that aren't ventilated, and that could be quite a problem. However, when we get there, it's typically the intake grill bringing air in from outside, especially if it's got an insect mesh in there. We actually remove those now. If the grills are accessible, you could keep the insect mesh in, but someone does need to know to go around and give that a clean. So maintenance and servicing, for the purpose of this, we're going to refer to maintenance as regular upkeep, yearly, 6 monthly for filters, and that's just to make sure that you're keeping on top of everything, making sure the system is performing to its optimal specification as it's being designed, so you're getting the right airflows constantly, and that's not stopping. It's completed yearly in private housing. It's mostly done by the end user. With social housing, obviously, whether the tenant does it or not can be a challenge. So we do try and train maintenance teams who are already on site up to do that yearly servicing, because there is no specialist knowledge required. So with regard to changing the filters, these need checking 6 monthly, ideally changing or cleaning 6 monthly too. So the filters are just in the front of the unit. You can see it's got, this is an example of a unit, this is a Zenda unit. It's got a black flap there labelled A, which folds down, and then you've got 2 grey covers that you just pop off and you slide the filters out and slide new ones in. So it really is something the end user can do. In your kitchen extract air valve, you'd also have a filter in there ideally to stop grease entering the system. Obviously, if grease enters the ducting system, then air is going to collect in there. Dust is going to collect in there much easier. Cleaning of the extract air valves, and again check the intake grill for blockages. So that is the regular maintenance that is required. So as you can see here, there's some pictures. I did have the before and after pictures in there, but you know, you can kind of imagine what it'd look like afterwards. So as you can see on the top left picture, that is an extract valve that was in a bathroom, and that is after a year of the system running. So it doesn't take long for it to get like that. We do label the air valves, so once we've commissioned the system and set it up, we'll label them so that if anyone decorates or removes it, they know where it goes back into. And that is completely normal. That just needs wiping off and putting back in. Obviously, the bottom right one, there is quite a considerable buildup of dust there. That one was, I think that one was 5 years. And then on the top right, we've got, that's a kitchen extract where they didn't put a filter in it. So any designer really should be looking to put a filter in there, because it's attracted insects that have got trapped in there. And then we've got the intake grills. So you can see that's got an insect mesh on it, and it's collected with airborne debris, there's animal hairs, there's bits of leaves, and the air is going to be really struggling to flow through there. Because the fans in the units tend to be constant volume, that means that even if there's a blockage on the intake grill, the fans will work harder to draw the air through it, which can then mean that the system becomes noisy in the plant room and also audible in the habitable rooms, which can be a sign that your system is overdue servicing. And then we've got filters. So you can see on the top, that's black. That is beyond needing changing. This system hadn't been serviced in 6 years. And then below is the clean one that goes in. Some people will hoover the filters out, but you're not getting all the fine particulates. So on my system, I personally change them every 6 months, and that makes sure that the system's running at its optimal efficiency. If you're not getting the small particles out of the filters, then the fan, again, is having to work harder to draw the air through the filters, therefore using more energy. Servicing, so this is quite an intrusive inspection and cleaning by someone experienced. So it does need to be someone experienced doing this for yearly servicing. There's our experienced person, Rick. Most manufacturers do suggest 4 years to keep on top of it. And that'll include removing and cleaning the heat exchanger, cleaning the fans. So even with the filters, you will find that after a few years, you start to get some fine particles building up on the internal components, just very fine dust. We've seen some systems where the intake filter, so the filter that's removing the debris coming from outside, that filter has been removed and the system has been left running without it. That's someone who didn't want to buy a new set of filters. And you'll see a picture of what happens if you do that. Cleaning the sensors. So the units are becoming more intelligent. They do contain sensors such as humidity and temperature sensors on the intake and the extract air. If they become covered with thin layer of dust or grime, then we can give false readings and we can send error codes to the system. So they do need cleaning. And run a fault diagnosis. So some faults might go undiagnosed, and it's nice to be able to nip them in the bud before we cause damage to any other parts of the system. As mentioned by Martin, after a period of time, you know, especially with dust build-up in the ducting, if it's not cleaned properly, the airflows will change. So at a 4-yearly servicing interval, you typically expect your engineer to go around, check the airflow rates are still as designed and commissioned, and make any adjustments required. I am in a room with an MVHR system and it is over-ventilating for one person, hence the irritable throat. I need to turn that down. Servicing is also a great opportunity for us to provide a fresh handover to the client. So often, you know, when we commission the system, we give a handover to the client, but they've also got a lot of other things to consider. There's the air source heat pump commissioning, there's the actual physical moving in of the house. So it doesn't always sink in. So 4 years later is a nice time for us to say, right, here's how to use it again. Any questions that they've got, we can answer. And we also suggest it for new tenants, and also if anyone buys a house with an MVHR system, we suggest servicing to make sure it's clean, but also to tell them what it's doing and how to use it. So as I just mentioned, the picture on the left is somebody who removed the intake filter to save the cost of filters, which is about 30 to 35 pound a set. And what's happened there, you've got some quite large insects. Can't think of the name of them. I think I know them as daddy longlegs. And they've gone in there and they're now sat on top of the heat exchanger. They're creating resistance to the air flowing through that heat exchanger. Therefore, the energy consumption of that unit will be increased. They're also sat on the summer bypass flap. So when the system, when it's hot outside and cooler inside, will stop recovering heat to slow down the rate of overheating. They are sat right on that bypass flap in this particular unit. So the summer bypass wasn't working. Next, we've got a heat exchanger, which has got considerable mold growth on it. These need changing it's nice to check them every year, but cleaning every 4 years is fine. This system had been turned off. This one was in a social housing scheme. They'd turned it off because of the noise, and therefore mold buildup had occurred. We couldn't actually clean that one sufficiently, so it resulted in a new heat exchanger. We've then got a condensate drain in the bottom of the unit. During the heat transfer process, condensate is produced and it drains away to an internal drain point. Mold does build up gradually in there, so that needs checking. And what we'd do to check that is firstly we'd clean that one because it is quite a build-up, and then we'd pour a glass of water down that drain to check it's still draining sufficiently. And then on the right-hand side, we've got a picture of a fan, which hasn't been cleaned for 10 years. Like I said earlier, you do get some debris making it through the filters. If the filters become very blocked, there's a chance that air could go around the filter. So they need cleaning every 4 years, those fans, and you need to be very careful because they have balancing weights on them. So we tend to use a very fine bottle brush, a lot of patience and a lot of experience to clean them. Ducting. So this is quite a common question. Does my ducting need cleaning? What we tend to find is that the ducting that does need cleaning is immediately after the extract air valve. So you can see there we've unscrewed the air valve, and right behind it there's a collection of dust. So we just put our hand in there and clean that with a cloth. If it does need cleaning, you can get products such as this Frankischer duct cleaning kind of sponge. That's got a fish line that you'd feed through the ducting system and then pull it through, and it pulls the debris with it, and you'd also use a vacuum cleaner for that. In general, ducting is anti-static, so it shouldn't collect debris. It should go all the way back to the filters in the unit. People often ask, am I due a service? Basically, if you've not had a service in 4 years, 5 maximum, then yes, you are due a service. There can be a few signs that you're overdue a service, although you don't really want to get to this point. You want to keep on top of servicing to avoid these issues. So if air valves in rooms become noisy, it suggests the fans are having to work quite hard and there's a buildup of pressure in the ducting system. So you'd want to get your system serviced. Noisy ventilation unit, again, your fans are working quite hard, therefore the unit's producing more breakout noise. Stuffy bedrooms, you're not getting the ventilation you required, and you notice that in high CO2 levels. Steam not clearing in bathrooms, so if you suddenly notice, hang on a minute, this bathroom didn't used to steam up, but now it is doing, that could be a sign that you're due a service, unless you've started having hotter showers, obviously. And any other apparent lack of ventilation, so sleepiness, tiredness, things like that, suggest that a service might be due, and at least a recommissioning and checking of the airflow rates. So, in summary, maintenance yearly, filter change, or a clean every 6 months, 4-year intervals, and new tenants or buyers. What we often find with social housing is we might go to service 30 plots over a couple of days. We might only get access to 50% of those, and that is a very common issue that we come across. So Martin mentioned about externally accessible units, which is great. A plant room with an external door, for example, is ideal for us. That doesn't give us access to internal air valves, so we would need to get in to clean those unless there's a maintenance team or unless the tenant is happy to do it. Some tenants are on board with that. So thanks for that. Hope I've answered some questions. And yeah, look forward to more. Thank you.
Thank you very much, Tom. And always good to see lots of photos of issues and how to resolve them. Visuals are always great. Okay, we're going to move swiftly on to about 10, 12, 13 minutes of questions. So I'm going to start with the Q&A, and thanks for everybody that's been upvoting. Please continue to do that. So the first one with the most amounts of votes at the moment is for Tom Dollard, who's quite happy to answer it as well. With the condensation issues and MVHR issues, was this mainly about behaviour and operational issues with the actual M&E? So, Tom.
Yeah, very good question. We found that it was the design and the installation of the MVHR. So by design, I mean everything that Tom's just mentioned, the layout, the position of the MVHR, the length of ducting, the product itself, market entry MVHR, not a certified Passivhaus product. So that certainly made a difference. And then I'd say the coordination. There seems to be a huge lack of coordination, and perhaps it's knowledge and awareness of MEP systems such as MVHR, and how they're coordinated with the fabric, the size of the utility cupboard, the service zone. So it's a knowledge piece. It's a skills gap that I mentioned was key finding. It's very little of that is to do with how the resident uses it. Tom Hayward's mentioned a few of the things what the resident needs to do, and you think we all agree that's relatively little, unless they turn it off or crank it right up. It's not going to make huge amounts of difference. So yeah. Paul, you're on mute now.
Apologies. I'm going to deviate from the upvoting. Otherwise, Tom's just going to get a barrage, and I'm going to get down to where's that gone? Oh, there we go. So I'm going to pick on Martin next, who's agreed to answer this question from Mark Davies. On the homes to Passivhaus standard, do you have data from the homes to show the temperatures within the homes kept to 18 to 20 degrees centigrade in the winter, and they did not exceed 25 to 27 for 2 minute days in the summer without adding additional fan heating or cooling?
Well, yes, for the Wimbish study, we've got 10 years of temperature, humidity, CO2 readings for most of the 14 properties at 5-minute intervals. So if you want data, we've got a fair amount of it. There's quite a lot of it summarized in the reports on the website that was included in my presentation. So there are reports there, and if you're interested, you can read those. And if you want to go further beyond that, then I can answer questions. But yeah, I can tell you what percentage of the time individual houses were in different temperature zones.
Brilliant. Nicely answered. Thank you. And again, skipping around a little bit, but I will come back to the most voted ones, to Ulrika, who's kindly offered to answer this question from Callum Thornton. What activity was taken by the window manufacturer to rectify the issues that you mentioned in your presentation?
I wasn't actually there when they did the service visit, but my understanding is they mainly looked at the hinges, adjusted and lubricated the hinges when they were there, and then any sort of follow-on work that needed parts, we would then we instructed separately, but there wasn't too much. I think mainly the adjustment of the hinges and the lubrication dealt with quite a lot of the issues that Martin sort of flagged up.
Thank you. Nice and simple. So another one for Tom Dollard here. I'm concerned from reading the proposed FHS and revised Part L, wry smile there, that this will result in not enabling the use of low embodied carbon heating, e.g. MVHR, with a few direct electric heaters, forcing social housing providers down the route of lower fabric performance and heat pumps with a wet heating distribution. Yeah, unpack that one, Tom.
Yeah, it's a very good question, isn't it? And Kerry certainly knows her stuff. So yeah, it certainly is pushing people down a heat pump route, and so that creates a whole load of that impacts everything from the fabric. Suddenly you've got a lot of people saying, well, why would you go to something like Passivhaus, an enhanced fabric standard, if you've got a heat pump, even a very small heat pump? Why wouldn't you design the fabric to meet that capability for heating and hot water? It's obviously doing both. So in a Passivhaus, it'd be doing very small amounts of heat when necessary, and in many cases it won't be necessary. Residents won't turn it on, but it will be doing the hot water, which is, as I've shown in my presentation, is a significant part of that overall energy use. So yes, there is a potential issue there that the new regs are pushing people down the heat pump solution, but from what we've seen, that's not precluding a Passivhaus approach with electric heating and another hot water system. But it is quite rightly clearing people away from just electric heating without that attention to detail on the fabric. And don't forget the hot water, that's significant amounts of demand. So it's kind of answering your question. I think it is a risk, but possibly not as much. You still will be able to do electric heating with MVHR and small radiators. That's very possible with an enhanced fabric. And the conclusion from Building for 2050 is that if you go down a low carbon approach, you just focus on carbon, you don't get low energy bills. And I think that's what people are starting to understand, that actually low energy bills needs to be on the brief and possibly part of policy as well. And the whole EPC needs to be reviewed to show people that in a more accurate way.
Right. Thank you, Tom. And then flicking around a bit to give Tom a breather, to the other Tom. Do the MVHR units have humidistats? You might want to explain for those people who don't know what a humidistat is first, if you're happy to, and then answer the question. Thank you.
Yeah, so a humidistat is measuring the humidity in the internal air. So there's a sweet spot for relative humidity, and that's between 40 and 60%. So some modern units do have humidity sensors built into them, and they will detect a man-made spike in humidity and increase the ventilation rate accordingly to clear that and bring the relative humidity back down. So in short, yes, we do.
Thank you very much. And then another one to Tom Dollard. Did you do an assessment on life cycle costing for these assessments? I would imagine it was replying to one of your presentation case studies, i.e. was an assessment done on the regular maintenance serving costs along with notional lifespans and replacement costs for all components? These costs need to be covered by a landlord's rental income and its fine balancing act to keep rents affordable.
Yeah, I think Paul's answered his own question there. So that's a good point. We didn't do life cycle costing on those case studies, but we did do some analysis of life cycle carbon, which showed the issue of going to a high performance, high tech approach with a relatively long term, say 25-year payback in case study 2. So I think that's kind of fuzzy logic, and I think that needs to be completely reassessed from regulation and client brief point of view. You shouldn't be fundamentally asking for a high-tech building that spends a lot of carbon up front, a lot of money up front, in the hope of it paying back over 20 years. You know, you should be looking at a max 5-10 year payback in terms of carbon and cost. And that goes with enhanced fabric as well. You know, are you prepared to spend a lot of carbon up front in terms of more insulation, better quality of fabric with a payback in the future in terms of carbon emissions and cost? So it is a fine balancing act, and we would always, on any of my projects, we would always do that assessment early on, that life cycle assessment, retrofit versus all the sorts of types of new build standards that you can look at, and the costs as well, the maintenance costs as well included in that model. And I should add that the Building for 2050 case studies are not certified passive houses, although in the brief, many of the clients requested passive house. There were lots and lots of barriers, and we've discussed that in the longer report. What are the barriers to passive house? And they're wide ranging. They start with cultural issues. Then they trickle down to knowledge and skills. And not having a passive house designer readily available is a lack of skill, lack of awareness. Kind of distrust of a new standard. It was a cultural issue. And then the technical, you know, the supply chain and cost. Someone mentioned the cost uplift of going to a certified passive house. So various barriers that meant that these 2 of the case studies, although they were started off as being passive house design, even up to planning in 2 cases, they weren't delivered as passive house case studies and certainly weren't certified, which I think is a you know, I'm possibly jumping a few logic. Well, I'm not. I think it's very logical to then say, actually, would these case studies, if they had been certified passive, would they have had less problems on site? And I think you can surmise that if you look at other research that others have done, various studies, Leeds, Beckett, UCL, Oxford Brookes have done monitoring passive house projects that show you have a far reduced performance gap. You still do have a gap in many cases, but it's certainly better quality. Going to Martin's point, if you invest in the quality of a construction, you're going to have better outcomes longer term, is the finding. So thanks.
Thank you. And there's 3 here that sort of gravitate around Tom Haywood. I'll just pick them up in the order that So somebody has asked, would be great to have washable filters as a tendency not to change every 6 months due to cost. I think you mentioned there that they can be vacuumed, but your preference is to change them. And I think you did give us an indicative cost there. That was about £35 or something.
Yeah. So they can be vacuumed. if you're monitoring the energy usage of your unit, you will find that it doesn't go back down to what it was with clean filters. Washable filters, so the kitchen extract, for example, often come with an aluminium filter in there. You can clean them. I know that people don't tend to clean them. Similar with a traditional kitchen extractor hood, you do see them in quite some states. There was also a question about recycling filters. You can, a lot of them now are paper. There has been plastic ones in the past. You'd have to check with your local authority on how best to recycle them. But there has been an issue with considerable amount of plastic used in filters in the past.
I guess there's probably a balance there. If cost and other considerations, it's probably best if it's best to have them washed or vacuumed than not replace them at all. I guess it sounds obvious, but that's clearly
yeah.
But if they can, and there doesn't sound like to be massive amounts, but if it's £35 every 6 months, £70 a year, just to factor that in somewhere. So I suppose the answer to the question is there are washable filters, but there are it's just one option. The other one for yourself is do the more modern controls for MVHR systems include remote monitoring and fault diagnosis, like we are starting to get on heat pumps?
They do, yeah. So they can be often connected into BMS systems, or they can be accessed remotely. So we have some, for example, where we can dial into those units in the office, and they might be at the other side of the country, and we can check faults, check performance, check humidity levels in the house. So yeah, that is possible.
Great. And another one here. Roughly how much, Tom? Sorry to you, Tom Hayward again. Roughly how much does maintenance and a 4-year service cost parts and labour? Always a tricky one with costs of this, because I'm sure it depends on a number of factors: geography, size of system.
It does. Yeah, it does. So I mean, typically I'd allow for £200 should cover you. It's good to, let's say, if you asked for servicing from us and you was in Norwich, we'd contact 20 other people in Norwich to see if they're ready for a service and tie you in to bring that cost down. So yeah, if you allowed for £200, with large social housing schemes where they're all next door to each other, obviously you can service 5 to 10 units per day, so that cost would come down drastically.
Right. I think we will pull a close because numbers start to drop off. That's usually a good sign that we're getting close to the end of the webinar session. There are a few other questions in there. Some I might just pick up with the individual that's asked because they're quite specific, and we'll have a quick whiz through, see if there's anything else that we can answer directly. So I'd like to first and foremost thank all of the speakers for their time and their expertise and pulling the presentations together, putting you all their knowledge. And one final, before I do this next slide, is I'd just like to give Gwilym from Max Fordham just a 1 minute. So unfortunately, Gwilym couldn't join us right at the beginning. Max Fordham are our other sponsor. So Gwilym, would you just like to quickly tell us about Max Fordham and just introduce your company, please?
Cool. Hi everybody, so I'm Gwilym from Max Fordham. We've got experience acting as passive house designers, MEP consultants, acousticians and sustainability consultants on a range of passive house schemes, including some multi-resi ones like Agar Grove in London and currently Greenhouse in Manchester, and a range of others including retrofits. And yeah, I really enjoyed the different talks today with the information, the knowledge share and so on. It's been really interesting, giving me a massive reading list to follow up on afterwards as well, which is great. And the Q&A has been really good. And yeah, when we see passive house as a key ingredient in a built environment response to the climate emergency, so we're really pleased to sponsor the series. Thanks.
Thanks, Gwilym. So the final slide is the Learn More one. So these are the guidance papers available on the Passivhaus Trust website. All of this information will be in the party bag, the electronic party bag that Lynn always carefully creates and sends out after the event. And then we've got, so there's the social housing one, the good practice guide on how to build, and a more recent one, steel in passive house construction. So I'd urge you to all have a look at those and put them on your reading list. And then the next slide, please, is our up and coming event. So we've got in April the official first one of 2024 in the Passivhaus Social webinar series, Passivhaus Social Housing and Net Zero. So there's a link there that you'll get in your party bag to sign up for that one. And then we also have the Masterclass Large and Complex link there, and also Future Build 2024 at Excel in London. So thanks again for everybody that's attended. We did hit at one point 237 people online, including the speakers. So that's quite a lot. And thanks very much for everybody's time. So we'll follow up anything that's in the questions and the party bag afterwards. Thanks to everybody.